Welcome to section 1.3 of Workplace and Apprenticeship 30. Today we're going to look at something called a scatter plot. And what that means basically is when you look at the data, we are not going to get a straight line. We're going to get a variety of arrangements. And here you see two different plots of data, and we don't know specifically what situations they come from. But each of them has a number of different dots which represent the information that was collected. And then there's a line drawn through the dots. Now that line is something called the line of best fit. So the line of best fit is something that is kind of arbitrary, which means that it's not a perfect science, but we draw a line that looks like the general slope of the data. And when these are both drawn, they actually end up being the same slope. So when we talk about, well, how are they alike? Well, they are exactly the same slope if we calculate the change in y over the change in x. And they're both positive because they go up from left to right. Now, how are they different would be a bigger question. And if you look at a language that we could use to describe that, you might say, well, these dots are more spread out. There's not as many as close to the line of best fit, whereas the one on the left, although they're very close to the line of best fit, there's just one that's off. What is some language we can use to describe that? And one is the concept of correlation. And if a graph exhibits strong correlation, what that means is that when you draw the line of best fit, most of the dots are really close. So this would be a case where there is a strong correlation between the line of best fit and the dots, and this would be a less strong or weak correlation because there's only a few dots really close to the line, most of them are scattered around it. A second thing that you can talk about with regards to language is an outlier. And now an outlier is a data point that is significantly different from the others. So when I look at the first graph here, I would say there's definitely one point that would be an outlier that maybe we would want to ignore and say, well, that's got to be a problem or a mistake. And when I look at the second one, I don't see any points that are drastically different from others. There's quite a few that are a distance away from the line, so I would say there's no outliers. Those are definitions you're going to need to write down. Let's take a look at another one. This is another scatter plot of information, and again, we don't know what the context is. But the question is there a strong correlation? Is there a line of best fit that can be drawn? And so if I just start drawing lines, even starting at 0, 0, does that represent the dots? Or maybe the line's going to go like this to represent the dots. I don't see a strong pattern, whereas in the previous ones, I definitely saw a pattern. The dots are going up from left to right. Here, the dots are going up from left to right. Here, I would say that there is no correlation among the dots. There is no line of best fit, so we couldn't really talk about those things in the context of a scatter plot like this. We can look at another situation here. This is a real situation, and it's talking about the fittings in connecting tubes on an aircraft hydraulic system. And these are the number of the fittings on one side of the graph. And on the other side is the number of fittings that are in the production run. And you can see that the number of fittings with the undersized inner diameter compared to the size of the production run changes as the number increases. And there's one point that's, I would call an outlier because it's way off. So some questions involving that you might be asked. Is this a linear relationship? Well, clearly the dots don't make a straight line as they are, but I would say there is definitely a pattern of dots that it's growing in this manner. And so if I were to take my straight edge out and draw a line of best fit, it might look something like that. Is that the best line of best fit? And here's where I said it's arbitrary. Everyone's going to be just a little bit different depending on what your choice is, but generally that would be the slope of that. And so if we want to find the rate of change, and I look at where it starts, if that's 50, I would have to estimate, the middle would be 25. I'd say that's at about 15, and that goes all the way to this value of 250. And it starts at 0, and it goes up to this height, which is at 7. So if I want to find the rate of change, it's the change vertically over the change horizontally. So vertically we went from 0 to 7. Horizontally, we went from 15 to 250. So 250 take away 15 is 235. And that would be fittings on the top. And on the bottom, there would also be another set of fittings. And you would change that to a decimal, I assume. So you can find the rate of change of a line of best fit. Is there a strong correlation? I would say it's a fairly strong correlation. You can definitely see the pattern. It's not very strong, but it's fairly strong because all the points are close by except for one. And the last question, which reviews 1.1, is this a direct relation or a partial relation? And how do you know? Does the graph go through 0, 0? If it does, it's direct. If not, it's partial. This one does not go through 0, 0. This would be a partial relation. And so, again, if we just look at another situation, this is involving fuel economy in two different vehicles, the red being one vehicle and the blue being another. Which is a higher correlation? I would say the red does, because most of the dots are closer to the line than the green or blue colored dots. Are these direct or partial relations? If we were to extend the lines, neither one of them would go through 0, 0, so they're partial. How could we write the linear equation for both? Well, there's two things that we would need to find. First of all, we'd need to find the slope value, so I'm not going to go ahead and do that, but if there's a rate of change, you might have to estimate, but you could find the slope value. You would also need to extend this straight back and see where it crosses your axes. And then you would say, well, this is my equation of a line. My m value is what I would find here. My b value is where it crosses the y-axis, and that's how you would figure out the equations. So a real summary of everything we've done in Chapter 1 so far. So here's your definitions. There were 4 new ones as far as I knew. Make sure you do your build your skills, ask questions, do a good quality of work. You can do the check. And when you're done that, you are done Chapter 1, assuming you've done a math on the job, and you can do your chapter review assignment. And if you're done that and you show it to me and everything's good, you can write your exam and then move on to Chapter 2. So that's it. I will talk to you again soon.